So, what is up guys, Jack here with another video. So, today I was recommended a very interesting video which I very much am looking forward to because this has something to do with what I do in the daily. And that is a video called How the Universe is Way Bigger Than You Think. A bit of an excess there on the what? Now, the thing is, I am in fact a physics student for those of you who are new subscribers or are just passing by this channel, and I do at the moment actually partake in a course for Cosmology, which is nothing better than
they always look up in wonder.
Looking at space stuff, to just make it very simple. Now, this is by real life lore. I love this channel. You should definitely go and check out more of the videos or even subscribe to them because they have served me a good bunch, especially when it comes to political things that I need to understand. It's not always my cup of tea, so it helps when a channel is dedicated to teaching you of that. So today, in fact, we could just rename the video to Physics Student React to How the Universe is Way Bigger Than You Think. So let's just get into it.
This is a real-life lore video made possible by Squarespace. Make your next move with a beautiful website from Squarespace. This is Earth. You live here on this planet somewhere, and everything that you've ever known is located right here. But just how small exactly is Earth when compared to the scale of the entire universe? Let's start by zooming out to where we can see our nearest cosmic neighbor, the Moon. You may think that the Moon is very close to Earth since it dominates our night skies, but in reality the Moon isn't this close to our planet, it's actually about this far away. 384,400 kilometers away from you right now on average. You could fit 30 entire Earths in between this distance, and if you somehow were able to drive a car at a constant 100 kilometers per hour speed, it would take you about 160 days to drive the entire distance.
Or 3 days in the modern
Despite this
rockets.
incredible distance, however, 12 humans have actually set foot here, representing the furthest away that any individual human has ever been away from the Earth, and one of humanity's greatest achievements.
Quick thing there, I love the size comparison. It's one of the fun thing that I have appreciated when professors actually do during courses or lectures, because you might sit down there during class, you get a theory, you get some formulas, and then you apply them. But you never truly grasp the understanding when you are not really able to model it. At least for me, because I'm a very visual person, given the fact that I stand here and edit videos also. I like the idea of actually having representations, which is why, for example, we tend to, one of the things that I like a lot, for example, is to use programs like Python or Jupyter Notebook is just an extension of Python, but where you can just model, for example, the planet's eccentricity using Kepler's law, and just having things visualized makes it a lot easier for you to understand. Now, when it comes to the Moon, a big question that a lot of people tend to ask is, why aren't we going more to the Moon? And the answer for that is very simple. The Moon is pretty damn boring. It's only something that was resulted from, the first impact on the Earth, when the Earth barely had any sort of atmosphere at all. And this, of course, culminated in the Earth getting more mass, but the rest of the residue assembled itself and, became what we know as the Moon today, this grey cheese. Why haven't we gone more there? It tends to a lot of things, both the lack of, new stuff to discover from the Moon. Think of it like this. We are already able to tell that from Earth here that Mars is a cold planet and does have icy lakes. So from here we can already do a lot of observation, and from there we can kind of know whether or not it is worth going to. And if we find some oil there, you are very sure that big businesses are going to be getting there before NASA actually do.
This is what the Earth would look like from there if you were standing there with them. And if you wanted to communicate with somebody back at home, it would take a message about 2.5 seconds to travel between you and them, since that's how fast the speed of light can travel at.
Actually, fun little thing. He did make the size comparison there of the 30 Earths and why it takes so long. Now, NASA is currently working on the Artemis project, which with the SLS rocket system launch. Space launch system, sorry. They're working on that, and their summation says that we should be able to do that distance in about 3 days. And it's, of course, very plausible. It didn't take too far either for the Saturn V or Saturn V rockets by Werner von Braun to actually send people onto the moon. It's an interesting thing that we are gauging ourselves into, because it's kind of like a training to knowing why we, how it is that the astronauts are going to be faring, how prepared will we be so that we do not commit a Martian. So let's keep going.
This is a photo that was taken on Mars. And
Very
the
quaint.
tiny dot that you see there is
Continuing
Earth
with
as
this.
seen from the Martian surface. On average, Mars is an incredible 225 million kilometers away from Earth, but that distance can be as high as 401 million kilometers. That means that whenever humanity finally gets around to landing a human on the planet, that person will be 986 times further away from Earth than the astronauts who landed on the moon were. In addition, the time delay for sending a message from Mars
18.
back to Earth isn't just 2.5 seconds, it's actually more like 20 minutes each
okay.
direction, which would render instant communication in the event of an emergency impossible.
Now, a fun thing that he might have glanced over, if you are interested in knowing, the reason why the distance to Mars was varying so much is simply because of, actually, the aforementioned Kepler's second law, which is applied onto the orbitals of the planets. They do not travel in circles, kind of like the Earth isn't essentially round either, because of the magnetic pull of it, of our sun. Now, putting it back into that scale, the planets will move in ellipses, and all depending on the eccentricity of so how wide, round, or more flat the ellipsis gets, you will have different distances. So the Earth will, in average, travel in that given distance from before, and at the worst be about those, what was it, he said here, is 200 and then 401 million kilometers, so yeah, almost double. So yeah, interesting stuff.
Emergency impossible. When we zoom out even further away, we can find the Voyager 1 space probe, which is the furthest away man-made object from Earth. It is currently located 138 AUs from the Earth. AU meaning astronomical unit, which is the distance between the Earth and the Sun, which means that Voyager 1 is 138 times further away from us than the Sun is. At some point on its long voyage, Voyager 1 turned its camera around and took this photograph. It may not look like much at first,
I'm
but
expecting
in my
a
opinion,
Carl
this is the
Sagan
greatest single photograph
quote
ever
here.
taken in all of human history.
Please do
this
it.
tiny pale blue dot is Earth, and I don't think that anybody has ever said something as amazing about this as Carl Sagan. He said,
yes.
If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you ever heard of, every human being who ever lived out their lives. The aggregate of all our joys and sufferings. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and every forager. Every hero and coward. Every creator and destroyer of civilizations. Every king and every peasant. Every young couple in love. Every hopeful child. Every mother and every father. Every inventor and explorer.
Tesla!
Every teacher of morals. Every corrupt politician. Every superstar, every supreme leader, every saint
Kim,
and sinner
of course.
in the history of our species lived there, on a mote of dust suspended in a sunbeam. Voyager 1 is currently traveling at 17 kilometers every single second, but even at that speed, it won't break out of the reach of our solar system for another 30,000 years. Once we go beyond the solar system, we arrive in our interstellar neighborhood. Here we shift to the light-year unit of measurement, which is the distance that light travels in a full Earth year.
In fact, when you're talking about cosmological distances, so anything that starts to get into galaxies and such, so, well, when you're looking at constellation overall, we are now converting into giga-years. The reason why we utilize giga-years, it is because light years are cool and all. It's fine, it's a fine scale, and it's very... The representation here does make sense. But the universe's age, in fact, is something that we know due to something called the cosmic microwave background radiation, or CMB for short. And it is essentially a picture, you could put it that way, of how the universe was in its infancy, because it still has the light of the post-Big Bang inflation. So this is something that occurred at about, I think, 10 to the minus 32 seconds after the Big Bang, and then the universe started its inflation, and then you have such thing as the introduction of the standard model. Now, to simplify it, you know how it is that in your high school physics or high school, even in primary school, you will be told what the elements are made out of. You have your protons, electrons, and neutrons. Now, these are components, or at least one of them is a component of the standard model as an already existing particle. The rest are made out of what are called quarks, which are elementary particles that are building blocks for the protons and the neutron. Now, the protons and neutrons are classified in what are called baryons, and the electron is what is called a lepton. Electrons interact with the electromagnetic spectrum, thus light, photons and such, which you might have heard of, or at least have heard of in movies. They always talk about photon blast.
And how is that supposed to prove to me you're not a Skrull?
That's a photon blast.
And?
A Skrull can't do that.
Baryons end up being the things that interact the most with the Higgs field. You might have heard of this, the God particle. They interact with the Higgs field and thus gain mass, at least a lot more mass than the electron will ever have, because light does in fact have mass. Thus, we, by looking at that picture, will see what and what do not interact with light, what ends up creating black bodies, which, if he doesn't mention this, I might come back to. So, to cut it short, we use the cosmic microwave background radiation to determine the age of the universe, and because the age of the universe is in fact a staggering 13.9 billion years, which is 10 to the 9th, we therefore use the unit giga for 10 to the 9th.
Or about 9.461 trillion kilometers. The star Proxima Centauri here is the closest other star to us other than our sun, but it's still 4.24 light years away from us. To put that into perspective, if it was heading in the right direction, it would still take Voyager 1 over 70,000 years to reach it. In other words, if you drove your car at 100 kilometers an hour like in our previous example to the moon, it would take over 6 times longer than the entire age of the universe is just to finally get there.
Which is why it was important that I mentioned that before.
Arrived. When we zoom out even further, we can see the entire Milky Way galaxy, inside of which Earth is located right here. This yellow dot is the furthest extent of humanity's radio broadcasts throughout history, which means that any possible aliens who live outside of this range are totally unaware of humanity's presence. It's complete silence outside of this yellow dot as far as we are currently aware, but the entire galaxy spans over 100,000 light years from end to end. There are over 100 billion stars and over 100
the only thing that they would have heard is jazz.
Our galaxy. But you have never seen the full glory of the galaxy at night, because 99% of the stars that you can see with the naked eye are limited to this small, tiny region right here. But even this massive galaxy is nothing compared to the rest of what's out there.
Now, before you zoom further, I guess it's just about the best time to say this. So I mentioned black bodies before. Black bodies, what they essentially are anything that is opaque. Black bodies are created from opaque material, so things that do not let light pass through. For they themselves do emit light of all wavelengths. They are essentially the Captain Planet of matter.
By your powers combined, I am Captain Planet.
However, there is such material that completely refuses to interact with any such radiation from the electromagnetic spectrum, called dark matter. And dark matter, alongside with another, well, vastly crazy thing that we still don't have a grasp on, called dark energy, are two of the biggest mysteries out there. Because not only are they not visible, they might interact with us, but we cannot detect them because they do not affect the electromagnetic spectrum at all, but they do affect us in a gravitational way, because we do know that they do influence the expansion of the universe. So yeah, 99% visible with the naked eye. Just a small point is very true. We do know we cannot see much, but we can still peer to the cosmic microwave background radiation, which is, as remember, 13.9 billion years away. So
Zooming out even further, and we arrive at the local group of galaxies, a collection of 54 different galaxies that is about 10 million light years across. But zooming out even further, and we can see the Virgo supercluster, of which the local group here is just a tiny segment of.
This monster.
There are at least 100 other groups of galaxies just like our own local group inside of here, and the distance from one side to the other is a mind-numbing 110 million light years. But even the massive Virgo supercluster is nothing but a quiet and tiny lobe of the great Laniakea supercluster, an enormous structure that is home to our galaxy as well as
the Hydra galaxy,
1,000 other galaxies. The distance from one side to the other is 520 million light years, but from even there we can zoom out all the way to the entire observable universe and see that even the titanic Laniakea supercluster is just a tiny and insignificant part of everything. This
is insane. You are here dealing with a diameter of 93 billion. Listen, just saying it sounds insane. But look at that. We are invisible to this. From our galaxy to our own cluster, it's magnificent to see that this is what is out there. It's crazy.
This is the observable universe, and it contains everything that we know of. It is home to at least 2 trillion different and individual galaxies, which together contain more stars than there are grains of sand on the
desert.
Entire Earth. The
the entire Earth.
The observable universe is
why not?
6.5 billion light years, which means that the entire width is 93 billion light years across. What's perhaps even more interesting, however, is what actually lies beyond the observable universe. Keep in mind that the observable universe is all that we can currently see, and it's entirely possible that the rest of the universe outside of it is vastly larger and more fantastic than we can possibly ever imagine.
And that's
we
where
simply
it kind of
don't
gets
know
into...
what else is out there.
Oh, sorry.
The light from these incredibly distant places has not yet had enough time in the universe's history to reach us yet back on Earth.
Now, this is where we kind of get into what we might call speculative. Or at least that's how I like to look at it. Because yes, it is very true. We might at that time be operating with more than light speed distances, and through that is here thing. So there are 2 or 3 rules in cosmology. One is that the night sky is dark. Duh, I know. The second would be that the universe or matter it's moving, or at least receding from each other at a uniform expansion. So things are moving away from each other uniformly, and so in other words, space is expanding. And the last one would be that cosmological constances do vary as the universe gets older. So the thing that makes it so damn hard for us to know is that a lot of the things are not constant. As I mentioned, the whole thing with dark energy and vacuum of space especially is that because of this inert energy that space actually has, we should be finding that space is contorting on itself all the time, but it doesn't. And the reason why that is that, for example, Edward Hubble, who is the guy responsible for example, the Hubble telescope, the guy who got the name for it and the prize for it, he got a constant named after him called the Hobble Constant, which is essentially, due to it, we can simply measure what the age of the universe is. It's just the reciprocated value of it. So 1 over h0 is the age of the universe. But the thing is that with his findings, seeing that things were moving far from each other, but we do not know why, because we do not have a grasp on those invisible things, so the non-observable part of the universe yet. And that makes things so much difficult. Because on local level, you can always apply such things as the Einstein's constants and his gravitational theories, right? It's very simple. But when you're looking on things where we ourselves are now feeling like the tiny particles that we observe in the lab, it gets so abstract and it's very difficult for us to handle.
And the light from some places may never reach us at all. Because some parts of space very far away from Earth are expanding away from us faster than the speed of light, that means that the light from these places will never, in an infinite amount of time, reach Earth. Meaning that even if humanity is eternal and exists forever, there will still be an unknown number of places in the universe that we will never know about or ever see. So, it is very likely that as unbelievably enormous as it seems, the observable universe is just a tiny slice of what we can currently see of the entire universe. According to the theory of cosmic inflation that was proposed by Dr. Alan Guth, if it is assumed that cosmic inflation began at 10 to the negative 37th of a second after the Big Bang, and with the assumption that the size of the universe before inflation began was equal to its age times the speed of light, then this would seem to suggest that at the present day, the entire universe is 150 sextillion times larger than the observable universe. That number for reference looks like this, with this many zeros. Let this number sink in for just a moment. This would be similar to you thinking that the entire observable universe, everything that you could see, was the size of a light bulb, but then realizing that in reality the entire universe is larger than the former planet of Pluto. Light bulb in the center of Pluto, but we inside the light bulb were totally unaware that Pluto existed outside of it.
This is so good.
That's a similar situation to this. We are all
this is beautiful. And of course, I like how they use the what's it called? Is it the 20? Was it 2012 that picture that was taken, or was it before that? Either 2012 or 2008. But it's actually pretty old, although it looks relatively new. But the tiny dwarf that is Pluto, rejected as being a planet. Yes, its moment of glory was given into this video. This is nice.
So unbelievably small, but you shouldn't worry, because all that means is that there is so much left out there for us to discover together. This video was made possible by Squarespace.
This is beautiful. This is such a well done video. It's very good. I love this. But again, as he mentioned at the end, there's so much to discover. While it might not be within our grasp, or at least not for now, it would be nice to see something like that happen. But then it requires that we move into, like, let's say, Nikolai Kardashev's civilization types, you know, when we are no longer just a type 1 civilization that have mastered their elements, their resources, and can utilize them effectively, but are now moving into like star systems where we are absorbing the energy from our star and are now traveling in light speed. Because as long as we aren't even able to to grasp light speed or pull an interstellar and travel through a black hole and end out somewhere, we're never going to be getting there anyways. But we have a lot of worries here on Earth to deal with, which is, I know, it's the argument that many tend to go back to. But thanks a lot for watching. This was even very instructive to me. I love the visual representation of it all, and hopefully I was able to provide some good insight for you and something relevant for you to take with you. So if you liked the video, of course, let me know by giving the video a like. If you didn't, sadly, give it a dislike. I like some fair criticism. Of course, if you want to see more of my content, don't forget to subscribe, because that lets YouTube know that this is a channel that is worth watching, and it'll let more of you to come back. And yeah, have a very good day, and I'll see you guys next time.